Now let's look at how the Internet enables you to access resources on the World Wide Web. The Internet is a network of networks, and it uses hardware and protocols to function. When you're at work, in the office, let's say, you're on your computer. There are other people working on computers, and all those computers are connected to a network. So you can send emails to your colleagues, for example. The routing of those messages within your network is done by a hardware device called a router. The network that connects these computers together is called a local area network. The router is connected to the Internet using a modem. When you need to connect to a resource on the Internet, like a web page, or to send an email externally from your organization, the router knows that you're trying to access a resource outside the local area network, so the router routes the traffic to the Internet. The role of the router is to keep traffic within a network and to route it outside the network when required. The modem actually belongs to another network also, and that's the network of the Internet Service Provider, or ISP, that your company pays to access the Internet. The ISP has its own network of customers. Those could be access points for businesses, like in this example, and they can also be consumer customers, like when you're at home accessing the Internet. You do that through a modem as well. And you can have your own network of computers and devices at home too, using a router to connect them on your own network. The ISP also has a router that routes traffic within the network, and when the traffic is meant for somewhere else on the Internet, the ISP routes the traffic out of its network and onto the network that the ISP belongs to, which could be a larger regional ISP. That regional ISP is also connected to a larger network. There are companies that operate networks that span cities and countries, and these networks are called the backbone of the Internet. They connect together in cities to move traffic all around the world, again, using routers to determine where the traffic should go. Of course, these are massive routers, not like the ones you have at home, but they serve the same purpose, to route traffic around the network and out of the network. Eventually, those routers find the best route to the resource on the Internet that you're trying to reach, like a web page. The reason all this works is because of protocols. You saw in the last clip that the World Wide Web uses the HTTP protocol for requesting and delivering web pages. It's really only your browser and the web server that speak HTTP. HTTP is actually built on top of two other protocols, TCP and IP. IP stands for Internet Protocol, and each device on the Internet has an IP address. So your modem has an IP address, as do all the modems and routers on the Internet. Within a network, your computer has an IP address also, and your router knows how to translate IP addresses between the modem and your computer. A web server has a public IP address also, and this is actually the destination your web browser is looking for, but more on that in a minute. There are a couple of different types of IP addresses, but IP version 4 is still the most common, and it's made up of 4 octets, so each IP address on the Internet is unique. Routers use the format of these addresses to know which octet belongs to different networks. When you request a resource from a web server, a package of data is put together by your computer, and that includes the IP address of the web server with the resources you want, as well as your own IP address, so the web server knows where to reply to. And by inspecting the package that's sent from your computer, routers on the Internet can route traffic intelligently based on that. The response data package is put together with the address of your computer, actually it's your router, as well as the address of the web server, so your computer knows where the data came from. That package also includes the web page you requested in the HTTP response. That's an oversimplification of how the data package is structured, but it's enough detail for our purposes. In reality, the data is broken into smaller packets of about 1,500 bytes each, and those packets can all take different paths around the Internet to reach their destinations. Routers on the Internet also monitor each other to determine the best path, so the path your request takes may not be the same path as the path a web page takes when it returns to your browser. The TCP protocol is used on computers to break up the packages and assemble them once they're all received. If a packet gets lost over the Internet, TCP is the protocol that knows to send it again. The last thing I want to discuss here is how your computer knows the IP address of the web server it's trying to reach. Remember in the previous clip, the user typed in a URL to the web page on a server. The user didn't type the IP address of the server, and you would never expect them to know that. Before your browser sends the request to the server, it needs to resolve the name of the web server to an IP address, and that's done using the Domain Name System, or DNS. Throughout the Internet, there are DNS servers that map domain names to IP addresses. When they don't know the IP address of a domain, they ask another DNS server up the chain until the mapping is found. If the domain name isn't found by traversing the hierarchy of domain name servers on the internet, then an error is returned to the browser indicating that. So that's a quick look at how the internet allows a user to request a web page from a distant web server. Later in the course, we'll talk about the role of search engines. But next, let's talk about the web server, because this is where we'll be uploading our website to.